Okay, next, we can differentiate using this rule when x is a raised to a fractional power as shown in the next example. Okay, so if you look at the example, differentiate y equal to x power of 1 over 2. Okay, so the solution, using the rule, if y equal to x power of n, then dy over dx equal to n times x power of n minus 1. We have n as 1 over 2. This gives the answer dy over dx equal to 1 over 2 times x power of 1 over 2 minus 1. So we will get x power of negative 1 over 2 over 2. So far, we have only considered polynomials which have a coefficient of 1. But how do we differentiate y equal to 4 x power of 2, where the coefficient is equal to 4? When we have a coefficient denoted as we have the rule, okay, so as we look at the example below, if y equal to a x power of n, then dy over dx is a times n times x power of n minus 1. Okay, so the note here is the first rule is just a special case of the above rule when a equal to 1. So going back to y equal to 4x2, 4x power of 2, we can see that the coefficient a as 4 and x is raised to the power of n equal 2. So using the rule, if y equal to a x power of n, then dy over dx is a times n times x power of n minus 1. We have dy over dx equal to 4 times 2 times x power of 2 minus 1. So we will get the answer x. Okay, so the important here is when we differentiate any function multiplied by some constant a, finding as the function below, we can take the constant a out of the derivative. So d over dx function a, we put out to be a times d over dx. Okay, for example, d over dx times 2x power of 3. So the 2 we times with d over dx times with x power of 3. So we will get the answer 2 times 3 x2, we will get the answer 6x power of 2. Okay, so if we look at the example, differentiate y equal to 4x power of negative 1 over 2. Okay, so the solution is, this example combines everything we have looked at so far. So using the rule, if y equal to a times x power of n, then dy over dx equal to a times n times x power of n minus 1. Okay, let's say we have a as 4 and n as negative 1 over 2. So this gives the answer dy over dx equal to 4 times negative 1 over 2 times x power of negative 1 over 2 minus 1. So the answer we will get is negative 2x power of negative 1 over 2. Okay, so let us look at for the chemistry example. Coulomb's law states that the magnitude of the attraction force between two charges decays according to the inverse square of the intervening distance r. Okay, let's say we put it as O equal to 1 over r power of 2. Suppose we plot a graph of attraction force on the y-axis against r, which is distance. On the x-axis, what is the gradient? Okay, so the solution here is to find the gradient. We find the derivative with respect to r, denoted dO over dr of k. So if we look at the equation example, O equal to 1 over r2, so we can simplify it as r power of negative 2. All the examples so far have only contained x and y. However, in this question we have the variables O and r. We know y equal to x power of n, and then dy over dx equal to n times x power of n minus 1. So with y as attractive force and x as direction, which is r, and n equal to negative 2, we have dO over di equal to negative 2 times r of power of negative 2 minus 1, and we will get the answer negative 2 power of negative 2 over r power of 3.